Hello friends, welcome. Today the video session is more about Java 10. Recently, in this month of March 2018, Oracle Corporation collaborated with OpenJDK. They released Java 10 specification and its implementation as well. They have some new policies, new features added to Java 10. So I got a chance to review Java 10. I have downloaded it. I found some of the features interesting and some new news from the community. I want to share all those details with you in this presentation. Along with this presentation, I just want to give an update to you. I am planning to do some tutorials on Java 9 as well because Java 8 has some new features, but most of us are aware of Java 8 lambdas, functional interfaces, optionals, etc. So I want to touch an area which is not much explored in our projects, which is Java 9 modular programming. So I am planning to do a tutorial on Java 9 as well. So for this video, we are just going to have a review over Java 10 features and we will wrap it up. Okay. So to begin with, so OpenJDK came up with some set of features or packed with some set of new announcements comes with Java 10. The first important thing to be noticed is time-based release versioning. I will just increase the font for better readability. Better readability will be good. Yes. Okay. So the first cool feature which we are needing to know is while releasing Java 10, the community came up with some time-based release versioning system. What do they plan is they want to introduce new Java release every 6 months. So every 6 months we will get a new version of Java. Days are gone. Earlier we have been waiting for 2 to 3 years for a new Java, right? So JDK 5, JDK 6, JDK 7, everything has some considerable time in between to get a new version. But now what the community planned is for every 6 months a new Java version will be available in our hand. This will keep the Java language more agile. So whenever a new practice or a new thing comes in the industry, the community is ready to grasp and implement in Java. So this kind of methodology or approach helps Java be agile and meet the latest things available in the industry. It is one of the welcoming and new good efforts from the community to develop Java. Right. So every 6 months the release will be there. So now in the March 2018 we got JDK 10, that is Java 10, whereas they planned for JDK 11 which is on September, 6 months down the line. On September 2018 they are planning for JDK 11. Likewise every new version will be released for every 6 months once. Fine. And they are going to release a long-term support version every 3 years once. So even though they release new version of Java every 6 months, there will be a long-term support for once in a 3 years. So once in 3 years, a long-term support version will be released. The first long-term support targeted for now is September 2018, which is Java 11. So we are now in Java 10. September 2018, they are planning for Java 11, which is going to be an LTS. So after that 3 years we need to wait to get another LTS from the community. So as of now this is the plan for the community. So for every month they will have some updates. Every month there will be an update release. So that update release will be named as 10.0.1, 10.0.2, etc. like this for every month, the first month, second month. So when it reaches 10.0.6, it will become JDK 11. So like that for every month, they will have some set of updates and released along with the versioning like this. Okay, so this is the new practice or new custom they are going to follow from Java 10. This is called as time-based release versioning. This is all about releasing Java and planning the milestones for Java development to the future. Right. So this is about the planning. Now, what's in Java. So what are all the changes they did in the Java structure or any new thing they have introduced? Yes, we have one new thing introduced which is called as local variables type inference. So this was very much famous and popular in languages like Scala, Kotlin, even in some languages like Go. So it is very much popular in languages like these things. The type inference is there. Now they want to implement type inference in Java as well, right? Even though we have type inference, Java still remains as a static typed language. Java is not a dynamic typed language. It is always a static typed language. But type inference is a new feature introduced to make our life easier while dealing with variable declarations, values, etc. So let us see a small example using Java 10 how type declaration or type inference is in effect. Okay, so I am going to open my command prompt. So I will increase the size for better readability. I am going to create a new directory Java 10 demo cd Java 10 demo. Sorry. Okay, so I am maximizing the screen. Now what I'm going to do, I'm going to set path to my Java 10. I have downloaded Java 10. I will share the Java 10 download link in the comment section below. Please get use of it. Before that, I will just I assume that I have downloaded Java 10. So I need to set path here. So my Java 10 is residing in, sorry, softwares hyphen 10. Cool. Bin. So I need to export it to my path equal to the same path with dollar path. So in Windows, you know how to set the path and all. So set the path up to the bin. Now I am ready with my Java path. So if I type Java version, it's showing me Java version 10. So it's getting installed. So 23 2018 is the day where it is released. And similarly Java C version, Java C 10. Perfect. Now I am ready to develop a simple example in Java 10. So I am going to open my favorite editor, Pico. So I'm going to name this code as demo.java class demo public static void main. It is an as usual our regular Java code I have written here. Right. Now what I'm going to do, I'm going to declare a string variable, right? Private string name equal to Java 10. It is a very simple code. What I'm going to do is system.out.println name. So I am done with my code. I'm going to compile the code Java C demo.java. Oh, okay. I have to make it as a final, right? Inside the function, what I am doing, it should be a final. Cool. Java demo. So my code returns it as Java 10. So it is a very simple code to print the message. Now, what's happening here is we are declaring a variable which is a string variable here. Now they have introduced something called as type inference, using which we are not specifying any variable types here. Simply we are going to mention the keyword var name equal to Java 10. So I'm going to compile the code. It got compiled Java demo. So the output is there. So even though I am not mentioning any data type here, no data types mentioned, but the compiler understands the type based on the value assigned. So this is what called as type inference. The compiler will infer the type for the variable based on the value assigned to it, right? So this is the first thing. So what about the scope of type inference? Within the function or within main, I can declare the variable, right? Now what I am doing is I am trying to change the scope. I am going to declare a global variable var. number equal to 10. Okay, let us see what happens. I will compile the code. See here, where is not allowed here. So what does it mean? You can use type inference only in the local scope. So type inference can be used only in local variables. So we cannot use them in global variables. No type inference allowed in global level. Okay, so this is one point. So only type inference is available in the local variable scope, right? So we already know this. Based on the value assigned, the type is being determined. So here it is a string which I have assigned. So the variable name behaves as a string. And now I am trying to do some other thing which is interesting. To the name, I am trying to assign value 1. Okay, so here already the value is being string. The compiler understands the variable name is a string and it is being printed. Now I am dynamically changing the type. I am dynamically trying to change the type by assigning a value integer. So the compiler is supposed to change the variable as an integer, right? That is what I am trying to do. But if I compile the code, incompatible types, the compiler will not allow dynamic type changing. That's why I am telling Java is a statically typed language. Once the type is being assigned or the type being inferred, then we cannot change the type just by changing the values alone. So dynamic type inference changing is not allowed, right? Because Java is a statically typed language. This is another thing. Okay. One more thing which I want to tell is it is not only restricted to the normal variables. We can use the same for some new type of variables also. What I can say here is, let us go one step deeper. So this statement is not allowed. So I am commenting this line, right? Now I am going to declare a list variable numbers equal to list dot of. I'm going to have a list of 3 varieties of data types: an integer, a float, and a string. So this is an interesting list. So far in Java, we have been dealt with lists of belongs to a particular data type. Now I have created a list with 3 different data, but I am assigning it to a normal var. So based on the data we are accessing, the type will be inferred. Right. Now I am compiling whether this code is syntactically correct or not. Yeah, list. I need to import java.util.list. So this code is syntactically correct. It got compiled. Now what I am going to do, I am going to print the values. Right? Numbers dot get of 0. So I don't know the data type. Just by asking the numbers dot get of 0, so what's residing inside the 0th index will be printed. Similarly, numbers dot get of 1, numbers dot get of 2. So even though we are dealing with different types of data, we are just trying to fetch the values from the list. We are not doing any type conversion or anything. We are just letting the Java compiler to understand the data we have assigned to and act accordingly for this list. So if I compile the code and run it again, let's see what happens. Java demo, you can see 1.2 data. All the values are being fetched without any issues. So whenever you want to or you are try to fetch the values from a list with variety or heterogeneous type of data, the type inference is very much useful for us to deal with. So this is one of the best important features or best important what I can say use whenever we deal with complex programming with the data structures. So this type inference is very much helpful. Already this feature is available in Scala, Kotlin, Go, and other leading languages of current era. In Java, they adopted this in this release. That is a welcome move from the community. This is all about the local variable types. Right. Now coming to the new change. So there is a new changes introduced to the garbage collector. So syntactically, programmatically, we have only one change is being implemented in Java, which is the local variable type inference. But apart from this, most of the things are happening internally. So a lot more stuff done to the JDK structuring and JDK garbage collections, memory allocations and all. So the feature wise implementation which is affecting day-to-day code is the only one feature, which is type inference. Now changes to garbage collector. What they did in the garbage collector? So far in Java 9 they introduced a new garbage collector which is called as G1, which is the default garbage collector. I am just planning for a new session for Java 9 to explain all these things in detail. For time being, it is just enough to know there is a new garbage collector named G1 introduced for Java 9. Right. So what the thing is, what here they did something creative is they just want to keep the garbage cell collector source codes separated. Earlier it is part and parcel with the JDK code. Now they separated and modularized the garbage collector source code. So it will be easier in future to add a new garbage collector, and our compiled code which is from the JDK build can even ignore the unnecessary garbage collector and all. So whenever we need a garbage collector, we can simply add it to our code and ship and build it up. So that kind of change is possible in the JDK 10 release. And the one more thing is parallel full GC for G1. What is the thing is G1 is the new garbage collector introduced from Java 9, as I told. What is the purpose? What is the reason behind creating G1? Already we have various garbage collectors from previous versions, right? Because in our code we may have some places which are eligible for garbage collector and some variables are ready for garbage collection. But what happens earlier in Java, they does the full garbage collection for the entire code, so that it takes more time and more effort and more memory footprint to get the variables released from the memory. For that, in order to avoid that, G1 is designed to avoid that full GC, because from the G1 garbage collector onwards they avoided full GC. So the only the partial GC will be happening whenever needed, and when the variable or when the what is that object or an instance is ready to garbage collect, that only will be collected. So there won't be a full GC cycle will be tied up with every garbage collecting call. So that is the main reason we opted for G1 in Java 9. But when working in the concurrent collections, we know that, right, we have some concurrent collections have been released in Java 9, concurrent hashed map, and lot more stuffs are there even from the previous versions, Java 8 and all. We have collections which are concurrent by nature that has been released. So when dealing with such kind of collection variables or collection type of data, full GC was happening. So what is the reason? Because the entire GC cycle is being handled in a single threaded way. So when you are dealing with concurrent collections, the entire full GC is being happened. And now what they did is they implemented a parallel operation of the full GC. So there is no, even when we use the concurrent collections, the full GC will be performed in a parallel manner, so that it won't have a single thread and it perform the garbage collection all the way serially or sequentially. Now it is being done in parallel fashion. That is a new feature they added to the garbage collector. Apart from this, there is a new thing called JIT in the JIT compiler, Grool they have introduced. What is it, Grool? It is an experimental feature of JIT compiler packed with JDK. From Java 9 onwards, they have introduced that Grool. So they are going to popularize that in the future versions, I suppose, but it is still in experiment. We cannot use it for production. So the JIT compiler, what it does and what is its use and all, we are going to see in the Java 9 tutorial session. I am also planning to cover the JIT compiler in this. But what the thing introduced in Java 10 is, using the command line we can enable the JIT compiler or we can disable it. That optional flags have been introduced in Java 10. An experimental version is this, but Java is heading towards implementing a production ready JIT compiler based on the Grool. So we can definitely expect some good things, but before that we should know what is a Grool, what is a JIT compiler and all. We will see it in Java 9 tutorials I am planning to cover. That is one of the good things. And another one is heap allocation. on alternative memory devices. So nowadays, Java is not only a part of desktop, it's being a part of mobiles, IoTs, and even devices, all the smart devices, everything can hold Java, right? So what they did is from Java 10, they make it possible in a multiple JVM environment to assign lower priority processes to use the dim memory. So it is how to handling the internal memory even for different devices, not only for computers, because the memory architecture differs from various devices, right? It is not homogeneous. So the memory access internally, how the heap objects organized, everything, they did lot of work. But exactly what internally happening for memory allocation and all, it is more technical. I am not that much aware on that front, but it is just good to know they did some revision on heap allocation for various devices or various memory architectures. That is a cool thing for better performance during the Java execution, right? And one more thing what they claim as a part of Java 10 is they introduced root certificates for Java JDK 10. Earlier, until in JDK 9, there is a folder called CA certs. It is empty because they don't have any certificates or anything, because these are all the things are part of security components such as TLS or anything for OpenJDK builds. They have introduced this is more kind of meant to deal with certification authority stuff. It is not much more for our programming thing day to day, but certification authorities and all, they will enable the certificates for the JDK package. So those certificates are now available in JDK 10. They provide a default set of root CA certificates, whereas in Java 9 they don't have much certificates because the CA sets source code for JDK is JDK 9 was empty. Now they have included some certificates for this to enable TLS and some other security components to use the TLS things and all. So this is all about a snapshot I have found in Java 10 at the first level. So there is not much more changes because everything is being planned for shorter milestones every 6 months. So they are looking to implement cool features every 6 months and they want to release. So we can expect frequent releases of Java. Between each and every release, 6 months will be there, but every release will not be loaded up with more technologies as we discussed, as we faced earlier. The technology change and implementation will be very little and minimal, but the release will be in very frequent 6 months and all. Some people feels 6 months release is very fast. It is really hard to adapt the changes, but it is a good thing where Java will keep agile and get updated as per the industry standards. So we have a buy-off. Yes, definitely the trade-off is there. The trade-off is adaptability to the new features. Definitely that is a pain, but it is good for the growth of Java. So thanks for watching this video. So as I told that I am planning to do a tutorials video for Java 9, especially for the new features introduced, because Java 9 is a totally shift in the paradigm how we program for Java. Of course, until Java 8 we have some cool things and greater way of Java programming, but Java 9 will change the way how you think in Java. So let us see that in future programming sessions. Please add your comments and your suggestions or anything if you have in the comment section below. Click the subscribe button. Don't forget to click the bell button to get updates whenever a new video get posted. Thank you.